So here's the next part of our lesson. First, we reviewed scientific notation. Now we're going to do a good review of significant digits. Again, really important when we're doing our calculations to factor in significant digits. So what we're going to do is go over some important rules for different examples for what we'll see for our calculations. And then when we get into some calculating in the next few lessons, we'll go over how to apply it to a particular problem. But right now we just need to know how to count them and what the rules are. So let's start taking a look. What is a significant digit? You might have learned about some of these in other courses, but what's the whole point of it? A significant digit tells you how many of the digits in the number that you're looking at are measured with some kind of reliability or accuracy. So to give you a good example of a different measurement, and you can have different accuracy and therefore different significant digits, would be when you're massing something. So let's say you're taking the mass of a compound in the lab. You could use an electronic balance. It might have 1 decimal place. It could have 2. What if it has 3? The more decimal places that the balance can read, the more accurate the number is. And that means when you report your number, you can report it with more certainty or more accuracy or significance. So measuring things, volumes, masses, that's usually where we'll see significant digits come into play. There's lots of rules with significant digits, so let's go over a few of them together. There's lots with numbers and zeros. So, first rule, if you have any non-zero digits, so not 0, but 1, 2, 3, 4, 5, 6, 7, 8, or 9, all of those numbers count as being significant. So if we looked at this number, 1,234 grams, this number is significant, so is this one, so is this one, and so is this one. All of those numbers are significant. There are 4 of them, so we say this measurement has 4 significant digits, or we can just abbreviate this as 4 SDs. So any numbers that are not zeros count as being important or significant. Now, next we start with the zeros. Depending on where the zeros are, there's different rules. So, zeros between non-digit zeros. So this means zeros that are in between any numbers from 1 to 9 are counted as significant. So here's a measurement, 307 liters. Here you can see the 0 is in the middle. It has a number 3 and a number 7 on both sides. 3 counts as significant, 7 counts as significant, and because the 0 is wedged between them, that also counts as significant. So 1, 2, 3. This number has 3 significant digits. 3 SD. Let's look at another rule. Zeros to the left of the first non-zero digits are not significant. They just help you indicate the position of the decimal point. So what does that mean? So if we take a look, here's a number, 0.004 kilograms. The zeros are to the left, these ones here, of our non-zero digit. The number 4 is our non-zero digit. This doesn't count, this doesn't count, this doesn't count. Only the number 4 counts. So this value here has 1 significant digit. Next rule. Zeros to the right of a decimal point might be significant. Now it depends on where you see them and what's going on. So let's take a look at a few of those examples. Here's 2. Now here, the first example, we see some leading zeros, zeros that come before the first non-digit 0. These ones here do not count as being significant. But if they are to the right of a number, so we have 2 and 3, and then look at this to the right, we have a 0, then it's going to be significant. So this one, and this one all count. 1, 2, 3. So that one has 3 significant digits. Here, we just have one leading 0. It does not count as significant, but the 5, the 6, the 7, and the 0 here, because it comes to the right, this one, all of them count. So if you have a decimal point and there are zeros to the right of any non-digit zeros, they are going to count. Let's go on to the next rule. When a number ends in zeros that are not to the right of a decimal point, the zeros might not be significant. So, as an example, what if we have 50,600 calories? This number could be counted as 3, 4, or 5 significant digits. So how do you know? The best way is to represent it in scientific notation. So what if we just had 5.06 times 10 to the 4? If we look at the number, we've got a 5, a 0, and a 6. The 0 is wedged between two non-zeros, so all three of them count here. What if, though, we put a 0 to the right of the number 6? This is the same setup. We have a decimal place, and there are zeros to the right of it, and there are non-zeros in front of it. This time all four count. The 5, the 0, the 6, and the 0. What if we put even another 0 to the right? Now we have 5 significant digits following the same rule. These zeros here are to the right of the decimal point, and a number precedes them that's somewhere between 1 and 9. So looking at the number above, when you see 50,600, this one up here, without any information about the accuracy, it might be an average, it could be 3, 4, or 5. But if you did want to represent using some accuracy, just put the number in scientific notation. It makes it a lot easier. Now, those are some of the most important rules that we're going to see. Now, what happens when you actually use significant digits with a problem? So there's rules. A lot of the time our problem solving will involve multiplication and division. So what's going to happen? So for multiplication and division, the rule is your result, your final answer, is going to be rounded off. So after you've done all your calculating, done all of your steps, you get to your final answer. It's going to be rounded so that it has the same number of significant digits as the component or the measurement that has the least number of significant digits given in the problem. So whichever number is basically the least accurate, that's going to have the fewest number of significant digits, we're going to have to count them, figure out how many there are, and then our final answer is going to be rounded to that number of significant digits. So let's take a look at this example. 3.0 times 12.60. If we count the significant digits here, we see the first number has 2. The 3 and the 0 count, 2 significant digits. The second number here has 1, 2, 3, 4 significant digits. So we're going to pause in a moment. I want you to plug it in your calculator and see what we get. But when you go to round your answer, we're rounding to the number that has the fewest number of significant digits. So since 3.0 is 2, our final answer here has to only be 2 significant digits. So take a moment and pause, do the calculation and round, and we'll check back in to check the answer. So hopefully you've had a chance to do this calculation and round, so let's check together. So 3 times 12.6 will give you 37.8. When we look at our answer here, it has 1, 2, 3 significant digits. But when we round our answer now, it can't stay as 3. We have to round it to the fewest number of significant digits, which means 2 because 3.0 is only 2. So we're going to approximate this number. We're going to keep the 3 here, but then we have to decide. This is going to be our second digit here. Are we going to round the 7 up to 8 or keep it as a 7? This decides on the number that's furthest to the right. Since this is above 5, then we're going to round it up. So this is going to be approximately 38. This has 2 significant digits. What happens now when you have addition or subtraction? This one's a little different. We see it pop up here and there, but it's not going to be every single time we do a calculation. So for this problem, you're going to round your final answer to the number with the fewest number of decimal places. This is different. So let's take a look at an example together. What if we have 12.753 and we subtract 2.45? So take a minute and put that on your calculator. What do you get? When you do that, you should get an unrounded number that's 10.303. We want to round this. So let's look at how many decimal places there are. Here in our first number, there are 3 decimal places. In our second number, there are only 2 decimal places. So which one has the fewest? This one here. It only has 2 decimal places. So when we go and we round our number here, we want 2 decimal places. So 10.3, and we have to decide what's happening over here. Do we keep it as a 0 or do we put it up to a 1? Next to it we see we've got a 3. This case we're going to round down because it's less than 5. So it's going to be approximately 10.30. Here in our rounded answer we have 2 decimal places. So there's hopefully a good review or introduction to significant digits. And again, right now the focus is just practicing on how to count them and what happens when you multiply, divide, add or subtract, and rounding your answers.